Hey everyone, this is API Basics Part 2. We're just going to be continuing off where we left off in Part 1. And in the last one, we were working on this Basics API repo, which you can see in the description. You can just download it and copy paste it and kind of reuse it as I'll be doing. And I'm actually going to copy paste this and going to start working fresh format so you guys can work alongside if you want. So I'm just going to call it 2 and just going to be putting it, running it um, right now. And okay, so let's, while we have the Gradle running, I'm gonna go over the goals for this video. So the goals are, in the previous one we made an API call successfully, and so in this one the goal is that we're going to wait 1 minute into it. So in this one the goal is that we're going to be learning how to better organize it so that we can reuse a lot of parts that we're making. So right now the classes are not public, nothing is really modular in a way in which it should be, and so if you've already made that code modular, then you might want to kind of skip a lot of parts that I'll be covering. But that's what we'll be doing, how to make it more modular. We're going to be learning how to create an interface so that we can, from the instance that we create from retrofit, and we're going to be calling an API client seed, we're going to be creating different instances, different API clients. So in this one we're going to be working with the post API client, and we're going to be creating static classes, and so you'll see that that will significantly condense the logic that we'll need. The next thing we're going to be learning is Lambda functions, how to use them, what they are. You can use these two links for reference, but I'll pretty much be covering everything that you need to know about Lambda functions for making the API calls. And we're going to be learning how to make these calls and log errors. So as I said, we're going to significantly cut down on the logic that we need on the main activity, and additionally we're going to also learn how to log errors with them if you want to, and learn how to write logic. So that's something that you'll see, that once we've kind of condensed the whole thing to a single line of code, it's going to get really easy for us to be able to write more complex logic within the activity. Okay, so let's get started. The first thing that I want to do is kind of get this class out of the way. So the first thing that we're going to do is kind of just take this out, and inside this folder that I have, test.connect.my application, I'm going to create a new package, and we're going to call it, so everything that you name, you should make sure that it's intentional, that you're making it in a way in which other people can work on it, that other people can kind of understand what you mean. So model is typically what an organization we use, where we store all the classes or basic interfaces that we deal with. So over here we're going to create a class, let's call it post, and so we're just going to copy paste the whole thing other than the public, and it's exactly the same, and we just go to the main activity and we make sure that that class is imported. Okay, and we're just going to make sure that the right class got imported. So the Gradle is running, which is why the the whole thing is kind of running a little slow, but we can take this dependency out, we can take this out and see. Yep, we are not getting any errors, that's good. Done. So as you can already see that we're around 50 lines of code. I mean, we started off with more than 90, and so this is one of the best condensation that we've done and probably will do, but the rest of it is also going to be pretty fun. The next thing we're going to do is, we don't want to be creating this retrofit instance every single time, so we're going to call it an API client seed, because we need it to create any API client. So we're going to call it an API client seed, and we're going to try to create a singleton. It's not like a true singleton, but it's pretty close. We're going to create a singleton in which we create this instance only once, and we reuse it. So there's going to be a lot of recycling that will be happening. So let's cut this whole thing down, and this thing is usually named in API client factory. I've seen it named, with a little bit of variation, but that's usually what companies usually follow. And we're going to be saving this instance as static, since just to keep the logic really simple, we're going to call it API client seed, and let's say every time that we need this seed, we're going to say retrofit. So the type of the method get API client seed, and we don't want to return this. So the first thing we'll do is, if we've already created an instance of it, so we're just going to check if it's null. If it hasn't been created, then it should be null. So we're just going to create one. Sorry, my computer is pretty slow. It gets frozen up pretty easily. Okay. So API client seed. Oh, we should initialize it to null so that we know for certain it's null. It's usually not something that I have a problem with in Java, but Java is written in C, and C throws errors all the time if you don't initialize something to null. It's just something to keep in mind. So if it is null, then we create this instance, else we just return the API client seed. And that's it. And the next thing is that since we want, for this one, we want to get the API client, so we're going to call this a public static. It's probably will need to be static too. And public static API client get API client. And so if you want to have a user client, like a client, like an API, it's a post API. So if you want to have like a client for users, a user API, or you want to have something for comments, a comments API, so you can just kind of create a new class, create a new interface, and just add a method over here. So always add a method in the factory, and you'll have it working. Let's call it get post API, and just name everything so that it makes sense. And we return get API seed dot create, and inside that we write post API class. Oh, so we haven't actually created the interface, so that's why it's being a little glitchy. Oh, okay, shouldn't have it inside the model. So we're going to create a package called API, and this is where all the factory, the interface, and any other logic related to API that we're writing should go. We shouldn't cluster everything inside the model. So this is another good lesson to keep in mind, and we're just going to push this, like drag and drop it into the API. Yeah, refactor. And so we haven't actually created a new haven't created a post API interface. So let's do that. Let's create a post API interface, and we've already written the logic for it, so we don't need to rewrite it. Go to post API, just copy paste this. API client, it knows precisely post API is now, and yes, it's done. Okay, let's get rid of this. We don't need any of this. Condense the logic, get post API. That's it. This should do the same thing. And we just have to import the static class, import static. We're done. We don't need all these methods. We're done. This should do exactly what was being done before. Why is it getting angry? API client factory 12. Oh, I'm good. I don't know, it's throwing that error at the bottom, but we're just going to run it, and it should hopefully do exactly what it was doing before. But as you can see, there's still, just to do this one-liner, just to do this one line of activity of function, we have to write 10 lines of code. And if this is something that you want to cut down even further and make it like an easier logic so you can build up to something interesting, it's something that we can definitely work on. So there's something called a Lambda function in Java, and so we've created the interface, different classes, singletons. Yes, we've created that. So Lambda function, what is a Lambda function? So well, these are some reference code. You can always go to a Java docs to have a detailed look at what it is. That's what I essentially use as primary reference for creating the methods that we're using. Or you can just visit W3 School. They have some interesting examples too. Oh, it still works. Nice. Okay. So here's what a Lambda function is. So non-Lambda function, let's say we're creating a function called adder, which takes two integers. Let's call them int a and int b, and usually a function looks something like this. So let's say int result is equals to a plus b, and we say return result. So Lambda function is going to look something like this: int a, int b, return a plus b. Oh, we don't even have to write return. I think this would be it. Or if you want to write multiple lines of logic for the same thing, or we can say int a, int b, and we can have curly brackets to write logic for us. So int result is equals to a plus b, return result. Okay, that's it. Or if it's something that's just taking one argument, for instance, we're just getting a result and we just want to print, we can literally just do result dot toString. And so this is what Lambda function is. It just kind of makes the logic far simpler, and we'll see how these 10 lines of code can even become one line of code. So let's create a new callback function. So we already have a callback. Let's create a new, let's call it a slim callback function, and implements callback. And so as you notice that I'm not doing anything particularly different from what was done before. Should have created those methods with the T. Let's do that. Okay. So the T ensures that we're using generic types and we want to be able to use whatever type we want. But we're not doing anything interesting. And the reason why we're not doing anything interesting is because we haven't actually given a function to do something with the result. So we're going to create our first Lambda function. And I'm just going to call this thing a Lambda interface. So Lambda function comes in a Lambda interface, comes in an interface, and we're just going to call it Lambda interface. And we're going to call the function inside it, just do something, and it can be of generic, so it can be of type T, and we just want to do something with the result. So this should be enough for our callback. So let's call it Lambda interface. And let's create a constructor. Take an argument. The argument can be Lambda interface, and we say this dot Lambda interface is equals to Lambda interface. This should be good. And so now that we have the function, we can actually do something with it. So this is where the response stuff is happening. So response dot if successful, then Lambda interface dot do something, and over here we say response dot body. So we're kind of being guaranteed that there's going to be a body now that we've checked for success. Now, but what happens if it doesn't succeed? When it doesn't even give response, it just goes for failure. We have no way of knowing. We can actually change that because we can create two constructors, because in Java you can do that. Every function hashes to a unique value, so the parameters kind of go into the equation which hashes those things. So we can just do that. We can just add, let's call it a tag. So we're going to call it a log tag. So this is going to be really helpful once we want to see what went wrong inside the logcat. So we're going to be logging for errors. So this is going to be very good for debugging. So let's do that. So if it's successful, do this, else we want to log it. So let's import this and class, and we're going to be using log tag, and we'll get something useful out of it. So we should get the code. I mean, this is like the very basic thing we should be getting. And we should be getting, if they manage to give us some message of what went wrong, we might get that too, but not the most likely thing. Usually a code is all you can get, and you can always Google what that code means, and that would be very, very helpful. Okay, so we have everything, and this is if it fails, if it's not successful. But what if it throws an error? If it's a failure, then we should get something over here too. So let's just copy paste this log and say thrown should. That's it. So we've logged something, but what if we want to use our own custom tag? And so as you can see, that's one limitation which we can very easily overcome by just creating another constructor and giving a custom tag. There you go, done. And so we go back to the main activity, and here's how we can use this Lambda function over here. Instead of calling the new callback function, we can call the new slim callback function, which has the return type of post, hopefully, or which is using the type post. And inside we can say, well, if we get a response, then we can, and let's do something interesting with it, because the API call is kind of done. We can right now write some logic for it. So let's say so let's call it string result is equals to and response dot, so ID is the first thing that we get. So let's create some sort of a string for that. Let's say ID and let's see what else do we got. Response dot get title, so we get a title. And I mean, we can just do that, the same thing with everything. And the next is body. So body we kind of renamed in the previous one as get big test, so we can just use that. So that's it, we're just putting everything inside the string, and as you can see, we can just do API text1 dot set text, and inside that we can just put whatever we got, whatever we made. So we can have quite a bit of complex logic inside, and as you can see, we're still 30 lines of code. And we can actually log an error to, like, a custom error, custom tag for first API. So have a custom, and let's see if this works out. And hopefully we by this point have covered pretty much everything we set out to. So yeah, we already have a program running, so we don't want that running. To kind of terminate that, kind of install the new update and have that thing running. Here we go. See you in the next video.